Alright, 5-minute video, draftphysics.com, debatephysics.com, 5 minutes or less, hopefully, explaining a simple problem that's come up. And so this video might only be temporary in case somebody has some reasoning or something to apply that will, break the ice, so to speak. It's about kinetic energy versus momentum and about how Newton's cradles function. I am contending that Newton's cradles will always conserve the total momentum. That is, whatever you put in, no matter how you put it in, whether just one object moves or two objects move, the momentum of what you put in must come back out, because there is no loss. The system is essentially lossless. There's a little bang, little tiny losses, but no substantial loss in the system. So whatever you put in, if you put in 50 here and 50 here, it has to add. You get 100 out. And in all cases, that's how it has to happen. Now, they're arguing that they can have 150 go in here and 50 go in here and get only 100 out. So even though you have twice as much energy in this example, the same amount of motion of metal, of objects, moves. So to me, this is the same as them saying that I could have a car accident between me and another car, and the two cars, could have just 50 as their momentums, and I have a crash. And what I'll get out is cars moving, because they're going to be elastic. That is, they're not going to bend or crush. But even if they did, there would be a certain amount of crushing of their fenders that would be commensurate to their momentum. The momentum will decide how much metal gets crushed. They're essentially saying that I could have 3 cars crash into, one car doing 50, and I'll get exactly the same out, 100. So 100. Same exact impact. So I could hit 3 cars, 3. 3 times the momentum, 150. 3 times the momentum. A truck. I could plow into a truck that's going 30 miles an hour. Let's say I'm going 30 miles an hour. And we're going to crash into each other. They say the outcome of the crash will be exactly the same as if I hit a single car. So I hit something 3 times as massive, going the same speed, 30 miles an hour, 30 miles an hour, and it doesn't make any difference. The crash produces the same amount of car moving. Now, obviously, I'm saying that's impossible. I'm saying it's impossible for Newton's cradles to ever not conserve the total momentum. That is, the total momentum, the total movement in the system, the total mass moving that you put in the system has to be conserved. And they're saying it doesn't. And they're saying it in this way that can't possibly, make sense to somebody reasonable. There's no way a reasonable person says, yeah, it's going to be the same crash. I can hit something 3 times heavier moving the same speed, and it won't matter. It's going to be the same crash. 150 of momentum, hitting 150 and hitting 50 will produce exactly the same outcome in terms of how much metal is moving. Now, need I say more? So no one will chime in with any physics authority. So let's see, physicist Michael won't really respond. So we don't have any authority pointing out what physics actually says. But if physics actually says there's no distinction between these two crashes, that the amount of metal is going to be the same. The amount of metal moving after the crash is going to be exactly the same, whether one of the objects is 3 times more massive or not. Then I say physics is clearly not physics. It's some other fable they're telling you. So, enough of a video, I think. It makes the point. The point is, Newton's cradles conserve momentum, and you can't do any free momentum experiments with a Newton's cradle, and you can't do any destroy momentum experiments with a Newton's cradle. It won't work in actual reality.